We're going to do a couple of things today. We want to discuss ratio division and what colinear means. I'm wondering if I need two L's there. Anyway, might not need two L's. And we want to then move along to look at the use of a thing called scalar product, which I like to call the dot product. And that allows us to then look at the angle between two vectors. Simple formulas. And then we can also see how sometimes your calculator can assist you to do those, because that will help, especially when you go and do 3D. So I will be doing the same stuff that we do now, 2D, with you guys. I'll be doing the same thing with my Year 12s, but 3D. Don't write anything down yet, Felix. You're so good at that, because I just want to start you off with simple situation. You haven't seen a question like this exactly, but you have the skills to be able to do it. So pop that one down. Today is the 14th, and let's see, can we solve it? We're just talking about what we were going to do today. This is just, I went backwards, so this was just to start the lesson, stuff that we have done. It's what we're giving you an example of is that you've just got a whole lot of simple vector properties and things that we do, and then we can hook them in with maybe some other algebra that we know and love. So just a random, unforeseen question, but you have the skills to be able to do it. So I just said, what would you do if these were actual numbers? Now, I should have actually said there, find what R and S is. But we're looking out and people were stuck and not knowing what to do. And what we could do is go, well, let's just simplify our left-hand side. And does everybody agree that my X component would be R times 1? That would have to be R. Yes? Plus S times 2, so 2S. Does that seem reasonable? And therefore you could do the same with your Y component. So what would that be? Thank you. I was waiting. I'm not going to do it yet. Plus 5S. Sorry for the pause on the video there. And now that equals minus 8 minus 27. I'm starting to get a little bit annoyed because people haven't got pen in their hands and working this out. Have you already finished? Have you done this? Then pen in hand and doing. Okay, next bit. Once you've got this, so this is a great example of you don't know how you're going to solve this until you write it down. So now what happens? Dave. Can you put it into simultaneous? He said, can we put it into simultaneous? Yes, yes you can. Because doesn't it have to be, this is your X component here. It has to equal this X component on the right hand side, because it's impossible. It is impossible for 3, 4 to equal 5, 9. It just doesn't work, all right? 3, 4 has to equal 3, 4. So does that make sense? So therefore, we've got R plus 2S equals minus 8, and we've got minus R plus 5S equals minus 27. You could go to the calculator and use your simultaneous, but before I even pull the cover off, I'd like to think that we have solved this, boof, by hand. Because, Mace, I've got R and minus R. So you can see really easily I could eliminate them by adding them together. Fantastic. So R plus minus R, no R. 2S plus 5S is 7S. Uh-oh. Minus 8 plus minus 27 is minus 35, isn't that nice? And so therefore S is minus 5. Sub that back in, and away we go. So you're going to get some practical aspects of vectors. You're also going to get just some algebraic ones, like so. And this is just adding vectors that you have done in your sleep right at the start of this unit. But you can see how we can build and just combine with other algebra bits and pieces. Does that make sense? Done. We had a couple of questions. What can be deduced from the following? So AB, notice the arrows, equals 3 CD. So that means it's 3 times CD. So a couple of things that we can, probably 3. that we could say about it? What's the first thing? Pardon? CD is not 3 times the length of AB. So AB is 3 lots of CD, so that means AB would have to be 3 times the length of CD, 3 times as long. Or you could say CD is 1/3 the length of AB. What's that something else that we could say? It is the same direction, and I guess that encompasses the next thing, that it is parallel. Does that make sense? And then RS, my father's initials, by the way, Richard Stanley, is -1/2 KL. So again, we would say that RS is half the length of KL. It is also parallel, but this time it's in the opposite direction. So no calculations to do, which is probably what you're thinking, oh, what am I meant to do? And yeah, do we get the... Now, with this one, this is actually a great question. I'm glad you asked this. AB equals 2 lots of BC, because this is leading into the bit that we're about to do with colinear. Because if we were to look at this and think about it, we've got AB equals 2 lots of BC. So what did we just say? AB is going like so. Would we agree? So there's A, there's B. Now B to C, they are parallel. They're in the same direction. So I can't really go off at a tangent, can I? It has to be continued on. Here's B to C, and this is twice the length of that. Does that make sense? So this is basically that ABC is what we call colinear. They make a straight line, as opposed to that. Okay, that's not colinear. We good with that? So we'll come back to this, and I'll write that exactly nicely as we have. But let's go back to the question. So question 2, more. Oh no. So we'll come back to 8. Triangle inequality. It's quite simple. It's obvious. But yeah, we'll do that in a moment. It was 2-7, I think I said on the exercise. We okay with 7? I can do it. I'm going to write this out by hand, but this is pretty much what I would do if I was making up a question along these lines. We have a point. We are heading off to point B. Let's call that XY. And we're going in the direction of 2, 3. Right? That's that way. If I had B going down here, it would be 2 and then -3. And we said we want to go 4 units along. Agreed? So what we're going to add is just our point of origin. And I don't care if you put the O here, the O here. It doesn't really matter, okay? Because we're just forming a vector equation. Right? Our vector equation is going to say that OB equals OA plus AB. Do we agree? OA plus AB. Now, OA is great. It's making you remember that how do I get, this is what we call a position vector. So from the origin, the position vector, I mean OA, we go A take O, so -1 take 0 is -1, -4 take 0 is -4, and we get this thing that, oh, we just change the coordinate into a vector to get its position vector. And Joe, that's going to help us because when I end up getting OB, well, I can then change that vector back to a coordinate. Agreed? Now, how am I going to find this AB vector? We know that it is in the same direction as this, but 4 units long. At the moment, if I just added on 2, 3, how long is that vector? Is it 1 unit? 3 squared is 9 plus 2 squared is 4. So at the moment, this has got a length of √13. Now, what you didn't hear on the video was they called out 1 unit. Now, they had the right idea. They have to change it to a 1 unit. In other words, they have to find the, let's get the language right, UV, not sun protection, unit vector. We have to find the unit vector, so same direction as this but just 1 unit long, and then we times it by 4. So can I do this, and is everyone happy if I do this? So 1 over root 13 times 2, 3. That is a direction, that is a vector in the same direction as 2, 3, but only 1 unit long. And then if I just times it by 4, now I've got 4 units long in that direction. Huzzah? So again, I think the actual maths here is very simple. But knowing what to do when, that is going to be your issue when they're all mixed together. So that's why we must pay attention. It's not a sit back and just go, oh, this is too easy, because it will get challenging when we mix it all together. So that will be 8 over root 13 and minus 4 plus 12 over root 13. And therefore, that means B will be the coordinate minus 1 plus 8 over root 13 minus 4 plus 12 over root 13. Now, if you pop each of these coordinates into your graphics calculator, it will simplify it for you nicely, like not having a square root at the bottom. We could do it, but we're just wasting our time at the moment. So as we talked about before, colinear means they're all on the same line. And you've got this in your book, but again, there's not only just one way to do it. So if we had 2 points, well, not 2, but if we have 3 points, they are colinear if AB equals K lots of, I'm going to say, AC. But you could also have the situation we've got to the right, where it could also be, if you've got AB equals K lots of BC. Would you agree? Obviously the K values will be different, and this is where K is a scalar. Except, what value couldn't it be? Correct. Obviously, because then it's just, that'll be the same point, not colinear. So all you're going to need to do is, if they give you 3 points, you go, yeah, work out the vector AB, and do we all remember how to find a vector between 2 points? So we just take them, we just looked at that before, and I know it was an easy one because it was 0. But if I wanted OA, I have to go A, take O. So if it was, instead of A and O, if it was P, 2, 5, AP would then be P take A. So 2 take 1 becomes 3. 5 take 9. Huzzah? So I have to get rid of that because people look at that and go, where has P come from in that diagram? And so if it is a multiple of the next one, so if I work out AB and then AC is half of this one, same, it could be a third. Just divide your X coordinates, your Y coordinates. If you get the same value, they're colinear. Agreed? I guess I'll just give you 2 seconds, not too long, but if we could just, that scares me when it's got the cross out, if you could try quickly do just question 1A, if we could at least do that, and then I'll talk about division. So try quickly, you didn't have to do all of them, right? You just do 2 pairs. So I went with AB, and then I like to go AC. That's just me. If you wanted to go AB and then BC, that is also correct, as long as you write it and you're clear. So I've done the AB, I've done the AC, and so therefore I can see that if I times this by 5 over 2, I get AB. Agreed?
So where have you got the 5 over 2 from?
Fraction work. I'm looking at AB equals, I'm just following this up. If you wanted to, you could go 2 divided by 5, 2 divided by 5, it's the same number, but I'm going, what do I times 2 by to get to 5? So times 5 over 2, and if I times this whole thing by 5 over 2, the 2's cancel, I get 5 over 5. Oops, 5, and that's AB.
Yeah.
So I'm just making sure I'm fitting into that thingy of saying it is a scalar times the vector, and therefore A, B, and C are collinear. We sweet with that? Joe's frowning at me. And this is in your textbook, but I do it just a little bit differently. And you can take it or leave it how I do it. You could go, no, I prefer the textbook. So look at what the textbook's done. We've got AB, similar to that last question we were looking at. P divides AB in the ratio 2:5. So we go 2 to 5. I think hopefully we all agree that OP equals OA plus AP. Now you could have said OP equals OB plus BP. Again, multiple ways to do these questions, and I'm going to show you a third. So OA, we can get that as a vector. Are we happy that this is 2/7 of AB? All right, A to P, it's part of AB, it's a fraction of it, 2/7. If, Sammy, if this instead of being the ratio 2 to 5, if it was 2 to 11, what fraction would AP be then? 2 over 13. You just add the bits together to get your denominator. So you zoned out then, that's why I'm asking you. So notice 2:5. So how many parts have we got altogether? 7 parts, and this is 2 out of the 7. Does that make sense? Yeah. So by all means, and then you just add, and you get your final vector, and therefore we can get our coordinate. Make any sense? I tend to use vectors right from the get-go. Slightly differently. I mean, it's the same. It's the same, but different. So I don't look at this bit here. I look at just the points, A, B, yes, we've got P here, -3, I just set it up, don't need. Now I could explain as I go, but I'm just going to mix it up a bit, and I'm going to write down a statement, and I want you to look at it and see if you go, oh yeah, that makes sense to me, or no, I don't know why you've done that, all right? It's the opposite, because we're saying that's, yeah, 2/7, but if I times that, it's with fractions basically, you're getting a common denominator, Joseph, this way. So what's the common number that 2 and 5 both go into? 10, and so if I times that by 5, and I times that by 2, I even out the ratios. And so now it becomes, it's 5. How do I find AP? Well, that's going to be x, take 3, so x plus 3, y take 2, equals 2 times, now PB, 5 take x, minus 1 take y. We all good here? What do you think my next step will be? Yeah, I guess multiply, but there's nice numbers, so I'm just going to do it all in one. Would we therefore, I'd say therefore, 5x plus 15 has to equal? Yep, 10 minus 2x. Everyone see? It's just my x component here has to equal that x component there. And, of course, 5y minus 10 equals minus 2, take 2y. So we can solve this. I get 7x equals minus 5. 10 take 15 is minus 5. And therefore x equals minus 5 over 7. I can solve this one. That will be 7y equals 8. Therefore y is 8, over 7. And so that means P is negative 5 over 7, 8 over 7. Let's just check. A same. I just don't have fractions right at the beginning. I bring them in at the end. So I'm not saying you must do it this way. It's whatever. Sometimes I'm in a mood. I will draw this and do the vectors. They all work. We happy with that? Okay. So can I give you a few moments and can you finish B? And then it's not very big, this little section. 2, 3, 4. And we still want to make sure that we can do scalar and angle between two vectors before we leave today. So just did a bit of a guess. Why did I put it in this order? Well, I did look a little bit at the x values. So obviously Q has to be the furthest right. Then I didn't just go P, Q, R. Right, so Q there, P was 3, so that has to come in the middle there, and then R. I really didn't bother looking at the y coordinates, but now I think, oh, good job going down, because that's 4.5, that's 2, and that's minus 3. If I had drawn it the other way, I would have gone, yeah, okay, I've done it the wrong direction, but I wouldn't necessarily have redrawn it, unless I got it wrong, then I would. Okay, so we show that they're colinear. How do we do that? Yeah, you can find any one we want. So we're going to go, you said Q, so which one did you want to find? PQ? Okay, so you want to find PQ. And we should be able to do these just really quickly now. So PQ will be 7, take 3, and minus 3, take 2. Happy days? Then what would we do? Right, we can go, so because I went PQ, just to keep my life happy, I would probably then do RP. Oh my goodness, RP, what do you get a shudder of? Research project. So RP, 3 take 1 is 2, 2 take 4.5. Minus 2.5. So how are we meant to show that they are colinear? You basically have to show that one is a multiple of the other, correct? Danny, you're annoying me today. Yeah? So a simple thing that we can do, I'm actually going to make my life a little bit easier. It feels like it's Friday today, but anyway, that's going to be minus 5 over 2. And now I do this. I'm going to go, what did I have to times, oh, this is very simple. What did I have to times 2 by to get to? To 4, 2, that's right. So could we all see, we can see that pretty clearly, that therefore PQ actually equals 2 lots of RP. Do we agree? Now, if you want to show it, you can, but I think this is pretty straightforward, that 2 lots of that, i.e. 2 times 2 minus 5 over 2 equals 4 minus 5, which is PQ. Right, therefore they are colinear. Now, how does that help us find the ratio in which the middle point divides the outer? PQ, oh, stuffed up. PQ is 2 lots of RP. Do we agree? So PQ is twice the length of R to P. So I should have actually put this over here. This is 2 times the length of that. Do we agree? Now, how can we write this? We could say that P divides RQ in the ratio of 1:2, or we could say P divides QR in the ratio 2:1. Now the book isn't going to write every single combination. So if you write one, you check answers, you have to read, oh yeah, am I right? That's the same thing. Obviously, if you said P divides QR and the ratio 1:2, then you're wrong. Okay, so another just little skill thing. It's a bit like, what's a unit vector? This is a thing called, what's the scalar product? If I have two vectors, let's call one vector A, A1, A2, B, B1, B2. The scalar product or dot product. Now, why am I calling it the dot product? It's a big old dot there. So sometimes you will see me or hear me talk and I'll go, dot product, just because it's in my head. But some textbooks also code it as dot product. And all we have to do is we do the x components times together, the y components times together, and we add them up. It's that simple. So a nice little example here, if I've got two vectors, 3, 1, minus 1 and 7, 3 times minus 1 is minus 3, 1 times 7 is 7. Now I'm thinking I should have put a different value there, but anyway, add them up and we get 4. What is the meaning of this? Absolutely nothing. But we will use this later on to find the angle in between two vectors and, very simple, and here comes the bit that you want to realize, and this is if, when I have two vectors and A dotted with B, if it equals 0, no other value, but if it equals 0, that tells us something astonishing, and that means that A is perpendicular to B. So if the dot product of two vectors equals 0, they are perpendicular. Opposite of parallel. Perpendicular. Should I write that? I'll write the word, sorry. Perpendicular. At 90 degrees to one another. So they're going to run through a couple of things. They're going to go, oh, here's two vectors just like this. Find the dot product. So you're just getting, Sammy, you're just getting used to going times that, boom, you get a value. Big whoop doop. Then they might ask you, here's two vectors, are they perpendicular? Or prove that they're perpendicular. And of course, you dot them together, bingo, bango, bob. And our favourite, they might even give you ones like this where you have the missing value. So let's go K, 3, and 2. K plus 4. This might backfire and they might not be. But if I say that these are perpendicular, find K. What would you do? 2K plus 3K plus 12 must equal 0, and now solve for K. If I'm really evil, I could put some things in here that turns this into a quadratic, and then you'd solve that. So again, we're simple mathematics, but we're pulling in some of our other skills to practice. I love it. Absolutely love it. I think we'll leave it. There is a formula for the angle, which I really want to look at, but we might squeeze that in before you go. One thing at a time. So for those playing at home, we skipped a little bit to page 92, okay? Simple, we get these. They can give you a whole lot of vectors and you will come up with these properties. They might even ask you to prove it. I like to prove it, prove it. Boom, 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 boom. So if they ask you to prove, you can see what they do. They go vector is V and W. I tend to use A and B. You could use P and Q, whatever you want, okay? But you just give them those, do the thing, and yes, left-hand side equals right-hand side. Are we good? So you're just working your way through some fancy pants ones, and I would like to introduce this to you, but it leads straight into the angle between two vectors. This is where we actually use the dot product. Okay? And all you have to realise is that the vectors do have to go out, out, out. So working your way through I, and if you can get to J, I'll love you for life.